So I did a K nearest neighbors project where essentially I watched a dating show on YouTube and I typed in all the pickup lines that people were using, and then I created like an algorithm to predict the efficacy of the pickup lines, and it works with a 63% accuracy. Um, and so first of all, one question was I didn't use it. I kind of used it using the tools that I learned in one of my classes, which aren't like industry standard tools. They're just like built in from the Berkeley API. Um, and then so that has to do with like, yeah, that's kind of what I wrote in the summary. Like at least it's better than just guessing.
Yeah.
But that goes to my second question, which was how do I like know how good that algorithm even is? Because I don't know what to compare it to. Like how do I address like how effective that even is?
Yeah. So you need a baseline. You need like you need to have a baseline algorithm or baseline measure of some sort, baseline prediction. And then anything you do that's more complex than that baseline, then you can proclaim that you have made an improvement or that machine learning is a suitable task for this type of problem. So for example, like, let's just say you're doing uh, your example is tough to come up with a baseline with. I would have to think about that and work through it. But let's just say you're doing like a linear regression, or let me rephrase that. Let's just say you're doing a regression problem, right? So if you're doing a regression problem, maybe a baseline model that you can build is just a simple linear regression, right? Simple linear regression with all of the variables input, right? Um, and find out, or even simpler than that, maybe even simpler than linear regression. You could say, you know what, I'm just going to predict the average value from the training set on all unseen data, right? And make that my baseline model, right? Simple baseline that will give you an answer. And then, okay, once you do that, you're going to have your mean squared error or MAE, whatever it is that you want. Um, and then from there build out more and more complex models to see what does better than that baseline. So you always need to have a baseline. um, so I would recommend checking out, I'll drop a link in the chat, but there's Jason Brown Lee from Machine Learning Mastery has a great um, article about just the importance of having baseline models in machine learning. So I highly recommend checking that out. But then also, man, just like that question that you're solving, like that project, that problem statement, like that's super interesting in itself. That would be enough for me to be like, oh, that's pretty interesting. Let me bring this guy in for an interview to talk to him about that project, right?
Hmm,
So this is
cool.
the importance of having really unique, different, interesting projects that you just find interesting, right? Um, right. And as long as you're able to paint a story about why you did that project and talk about it in an interview, make it interesting, and then walk somebody through your entire process. How did you collect data? How did you clean the data? Why came nearest neighbors and your entire thought process? If you talk about that not only in the project in like an executive summary, but if you talk about it in the interview itself, that's gold, man. And you know what? It gets messy experimenting with machine learning. I suggest you check out Comet ML's experimentation management platform as well, because I think the sooner you get comfortable with managing your experiments, the easier it will become when you're in the industry and working. And it's just part of more principled workflow as well.